So here we have our last question, question 11. Again, it's 50 marks. And if you have any questions or comments about the marking scheme, my email is on the screen there. So this is another 3-part question. You must do 2 of the parts, or you can do all 3 and your best 2 will count. Part C is an option question. You have part A or part B, and again, do one of those, or you could do both and your best score will count. So part A, a teacher is tidying out the chemistry lab store and discovered 3 containers which have been incorrectly labeled. It is known that one container contains K3PO4, another K3NO3, and another Na2CO3 or NaHCO3. A student was set the task of identifying each of the powders so that the containers could be labeled correctly. So part 1 asks you to describe how the students could have distinguished between the sample that contains sodium ions and the samples that contain potassium ions for 6 marks. So in here you to mention the color, blue color of the flame was changed to yellow for sodium, and for potassium, the blue color, the blue flame was changed to a lilac flame, identifying that as potassium. Okay. Outline the 2 tests that the student could have carried out to identify the sample containing the phosphate ion and the sample containing the nitrate ion. So for the phosphate ion, you have ammonium molybdate, and a yellow precipitate form. So you can see how you get your 3 marks there by mentioning ammonium molybdate and yellow color. For the nitrate, you must mention freshly prepared FeSO4 and must be freshly prepared, or iron sulfate, and concentrated sulfuric acid. So that's 2 and 1 there, 2 for the FeSO4, 1 for the sulfuric acid, and then a brown ring forms the junction between the 2 liquids, 3 marks for that. In order to determine whether the remaining powder is Na2CO3 or NaHCO3, some magnesium sulfate, MgSO4, is added to fresh solutions of the powder. Write a balanced equation for one of the 2 possible reactions. So you have Mg2 plus CO3, 2 minus gives you MgCO3, and that down arrow indicates a precipitate. You don't have to include that. And then Mg2 plus 2HCO3, 2 minus, giving you MgHCO3 twice. And if you include the full equations, that's fine too. Check your chemistry book just to make sure you have that correct. So the formula is 3 marks, balancing 3 marks. So that's part A. On to part B, which is a bonding question. The table shows the boiling points of some hydrogen compounds formed by group 6 elements. Explain why the boiling point of water is much higher than the boiling point of hydrogen sulfide. Well, water has hydrogen bonds which are stronger than the van der Waals forces in hydrogen sulfide. Explain why the boiling points increase from H2Se to H2Te. So they both have van der Waals forces, but H2Te is a bigger molecule or a larger molecule, so it has a higher boiling point. And the explanation is given there, but just if you mention the fact that it's bigger or larger, higher relative atomic molecular mass, whatever case may be, that's 6 marks. Would you expect H2Te to be soluble in water? Give a reason for your answer. No, because it is non-polar, whereas water is polar. And then draw a diagram to show the forces that exist between the molecules of water. And as long as you have the partially negatively charged oxygen and the partially positively charged hydrogen lined up with an indication of a bond between them, that's your 6 marks there. And on to part C. So you have an option here, part A or part B. So part A is atmospheric chemistry. It asks about ozone. So what is ozone? And use chemical equations to show how ozone is formed in the stratosphere. Molecules of oxygen containing 3 atoms is what ozone is, O3, for 4 marks. Then the chemical equations, you have oxygen plus energy, gives you the 2 oxygen atoms or free radicals. One of those then will react with O2 to give you O3, which is your oxygen. Then on to part 2, explain how the ozone layer protects the Earth. The ozone layer provides protection from UV radiation by absorbing them. Give account of the destruction of ozone by CFCs. Okay, so Cl plus O3 gives you ClO plus O2. Okay, and ClO plus O gives you Cl plus O2. And there is your solution there. So those equations are needed, both of and then that's a chain reaction, which the process repeats itself. So 3 marks there for the first equation, second equation, and then talking about the process repeating itself. And the radical dots are not essential, and that's the same with part 1. If you don't have the radical dots in part 1, you'll be okay. You'll get the marks there. Okay. And then part B, iron is extracted from iron ore in a blast furnace. Hematite Fe2O3 is a common iron ore. Coke and limestone are added to the ore, and hot air is blown through the hot mixture. Iron is a transition metal. State one property of transition metals. So there's variable valencies. It forms colored compounds and acts as catalysts. Any one of those for 4 marks. Coke plays 2 roles in the extraction process. What are these roles? And write balanced equations. So it acts as a fuel, or it burns or heats the mixture to melt so that you can reduce the ore. So melting the mixture is C plus O2 to give you CO2, and reducing the ore, C plus Fe2O3 gives you 2Fe plus 3CO. So you have your 12 marks there for those 4 different points. Outline with the aid of balanced equations the function of the limestone in the extraction process. So CoCO3 goes to CaO plus CO2, and then that reacts with SiO2 to give you CaSiO3. So 3 and 3 marks there for 6 marks. Objects made of iron may be protected from corrosion by the use of a sacrificial anode such as magnesium. Explain how this works. So the magnesium is oxidized more easily than Fe, and magnesium is higher in the electrochemical series than Fe. Mg forms cells in which Fe is the catalyst. So any one of those for 3 marks, which is the full marks there. And that is the end of question 11.